The code has been cracked for the world's first zero-fuel, limitless power system, and it has just changed energy forever by me, Curtis Herbold. Hey everyone. Like I said in the previous video, these are just some statistics. As you can see by my disclaimer over here, the probability of success, statistics, and power output may not be 100% accurate. This information is mostly to show the potential in a theoretical way, and we will not know the actual full output of this device or devices, because there's going to be multiple explained here, for sure until the first prototype is built to verify the math and physics. The device names that you will see are not final. They are just general names and placeholders and have no meaning on the final name of the device. So again, the names used are just general placeholders, mostly because I know how big companies are. If I give it a name now and give the parts it would cost, or the part names, they could build it themselves in fraction of the time. So, like I said in the previous video, before I edited this in, you won't get the parts. You won't get the parts at all. You'll just get the information required to prove my point of how potential this could be on multiple fronts. We're going to start with a 30-year prior and a 30-year future yearly global cost analysis if we were to switch over to this entire grid of my invention overnight, any snap. If we could just have magic powers and change every form of technology, any snap, overnight, this would be a 30-year prior as of today, 30 years ago, now and 30 years ago, and then what it would be if we had magic powers and could switch it in a snap from today and 30 years in the future at a yearly global cost. We're not talking about USA here, we're talking about global cost. We're going to start with that. Then we're going to explain the internal power source that I have for batteries. Not only how it could be for batteries, but how it actually also, my design also is within legal and safety laws. Then we're going to go to a small handheld power generator, where you have a power generator in the palm of your hand, like the size of an Alexa Echo Dot. All right? Then we're going to go into an example of a car engine with potential on how it could go, where it's also legal and safety compliant also. It's really, really cool. Now, then we're going to go to a one pillar design, like a house pillar, and I'm going to show you this stuff here. Again, no parts, no web links to the parts, just information on what it looks like, what it could look like, etc., etc. There is no parts listed in any of this in this video for safety concerns. However, I will say that there are optional upgrades or smart system upgrades that could be added to the base design that you will not see. You will not see any parts of the base design in this video. I want that explicitly clear. That way, people like the companies can't try to, bullshit their way, and steal my idea. I'm only making this video to explain the potential statistics, probability, and power output of the device based on my base design for all of these designs. Then I also invented a new power plant. That's right. I literally went and used decommissioned coal plants. I used decommissioned coal plants as a refit design. We could not, honestly, we don't have to just use decommissioned coal. We could use decommissioned oil, decommission gas, any decommissioned power plant we could use and reuse the components in there. I'll explain how that works as well. How we can literally use what is already available to us. And then we're going to end the video with the biggest possible thing ever. The future of space exploration, and not just space exploration, but human space exploration with mining in the asteroid belt. First ever, never been seen. What you're gonna see here is a bunch of probability of successes, statistics, and power output based on my base design that you will not see in this video. You may see upgrades, you may see potential smart upgrades, but you will never see the base design in this video for security reasons. It's that big, that huge. So this video may be longer than an hour, and I may not be able to upload it to TikTok. But I will try to keep it within the hour limit so I can upload it to TikTok, because this is huge and world-changing. So let's begin with the first of 1, 2, 3, 4, 5, 6, 7 documents I have made for this video and other reasons for angel investors, which apparently is going to be my staffing company, Avaunt Supported Living, Columbia, Missouri, 65203. Good company. You should look them up. I think they even do tours of their facilities, so look them up. I'm pretty sure you could probably get a tour. With that being said, let's begin. As you can see, my disclaimer is down here at the very bottom on purpose again. And we're going to start with, like I said, the 30-year prior and the 30-year future if we had magic powers and could switch all of it in a snap. The scope comparison applies to consumer electronics, phone, tablets, laptops, home appliances, industrial machinery, vehicles, gas, diesel, EV, infrastructure, grid, hospitals, data centers, satellites, and portable and off-grid devices. Category by comparison, 30-year total cost of ownership. Smartphones in the last 30 years for lithium batteries, replaced every 2 to 4 years, 300 plus total. Magnetic engine variant that I have invented, no battery, $50, self-sustaining module, 95% lifetime use. Laptop tablets, 30 years, the last 30 years, 500 plus adapters, 400 plus power cost. If we were to snap our fingers, $80 magnetic generator, no adapter or charging costs. Vehicles, ICE, the combustible engine. Everybody knows the bomb in your car. $30K fuel plus $15K maintenance. 2 engine replacements. But if we have my variant, my invention, $3K. We drop from $30K fuel plus $15K maintenance with 2 engine replacements down to $3K one-time cost, $700 maintenance lifetime. Now, obviously, because of tires and stuff like that, that's where I'd say it may not be 100% accurate. But the engine maintenance, at least, alone, just for the engine alone, not the tires, not anything else, but the engine alone, in explosive engines, now go from that to a $700 cost for a lifetime. Vehicles, electric, 10K battery, and 7K charging. And people want to already tax our power grid and make that worse by charging with electric cars. We drop that to a 2.5K closed loop power. No charging required. Home appliances, $15,000 in household electricity cost in the last 30 years. Do you know that that in the last 30 years, $15,000 in household electricity costs? I think that's much higher, personally, which is why, again, that disclaimer is down there. But we could potentially drop that from $15,000 to $4,000. That's literally an $11,000 drop in costs, potentially, if the numbers are accurate, for the entire home for 30 plus years. Industrial machines, 50K energy plus 20K maintenance. It drops to 10 through 15K install, 2K lifetime maintenance for industrial machines, potentially. Data centers. This is the big one. We know data centers hold a lot of our information around the globe, right? I did not know this statistic. I'm actually impressed, and I do believe this is far more accurate for this statistic than anything else on this list. $3 million a month in power, cooling, and backup for data centers. And with my design, that plummets like a rock to $500,000 to $800K setup with near zero ongoing power. Yeah. Then we have satellites in space. You know how we have the satellites in space? We could even consider the International Space Station in this because it is a satellite. Solar plus battery backups. High payload, weight. It's very costly to send a rocket up and refuel the batteries, fix the batteries, refuel the micropropellant, etc., right? That's part of the reason why the International Space Station is scheduled for eventual decommission. But what if they could implement this design, do away with solar, do away with micropropellant with the new theoretical space info that we'll see later for engines, and literally drop that cost for that to a compact closed-loop system with infinite runtime, reduced launched weight. And I generalize that, but what it is there, in order to literally change this over, it's not just reduced launch weight for a rocket, it is massively reduced weight for a rocket, whether that be a part for the International Space Station or a simple satellite. Remote equipment, battery swaps, solar logistics, $100K a year for fleet upkeep. Plummets to 5 through 10K magnetic system. No maintenance or field servicing. 30-year global cost estimates. This is, I think, far more accurate than people realize. Personal electronics globally for the last 30 years, $7 trillion. But if we were to implement it for all personal electronics tomorrow, that drops from $7 trillion to $800 billion. We potentially save $6.2 trillion in making personal electronics globally. Now, I won't explain that completely like that for each one, but I'm instead on the first one to give you an idea. Vehicles, $90 trillion last 30 years. For the next 30 years, drops and plummets to $12 trillion, saving potentially $78 trillion in vehicle costs. Industry, $45 trillion last 30 years. $9 trillion plummet with my variant, saving a potential $36 trillion a year. Infrastructure, as you know it, the power grids, power cables, power lines. That's the power infrastructure. So I'm going to stop here for a minute. It does say $35 trillion global in the last 30 years. All right? You're talking about power lines laid. You're talking about power lines put up, power lines, put in. We could actually turn the entire electrical grid into a self-sustaining system, or make all the power lines underground. We would save money because we wouldn't have to drill holes to put power lines in. We wouldn't need to put power cables in. It's fantastic. Saving potentially $27 trillion just for electrical industry alone. Data centers and the space it requires. $12 trillion last 30 years. With my variant in the next 30 years, if we were to switch it over, drops to $3 trillion, saving potentially $9 trillion. So in the last 30 years, based on the statistic, $189 trillion has been spent in the last 30 years for all 5 of these objects. That completely encompasses every single technology you can think of in the last 30 years. And if we were to implement this any snap like magic powers tonight, and every electronic device had this my variant, $32 trillion for the next 30 years. Saving potentially in the next 30 years on all electronic fronts $157 trillion potential dollars. Emissions impact for 1995 through 2055. Transportation CO2, 30 billion metric tons a year, just with combustion engines. My design, 0 emissions. Grid emissions, oil, coal, gas, nuclear, 25 billion metric tons a year. My design, 0. Local closed loop, potentially. Battery waste, like the cell phones, fit 30 million tons of e-waste. We're talking about cell phones, car batteries, regular AA and AAA batteries, you name it. We're talking about massive amount of batteries on all fronts dropping to a near 0 recyclable tech. Mining extraction for coal, gas, oil, you name it. It literally produces 50 million tons of lithium cobalt a year. Like crazy. That is the last 30 years. It literally cost us in emissions 30 million tons just for mining of gas emissions. And that drops to none. Rare earths recycled. Now, I know this is getting pretty deep. I'm pretty sure if you're sticking with this, it's already piquing your interest. Systematic benefits from 2025 to 2055, if we were to implement this tomorrow. No more chargers or power cords. Energy is generated internally. Never need to charge your phone ever again. Device. We'll get to the internal power source on those probability and statistics soon. Minimal maintenance. No fuel. No oil changes. No recharging infrastructure. That'll be covered in several other text tabs, as you can see at the top of the screen. Longer lasting devices. Fewer replacements, reduced e-waste. Distributed power, reduced grid dependence. More self-sufficiency. Job shifts from maintenance, logistics to engineering and manufacturing. Estimated battery fires and blackouts. Greater system safety. Bottom line, if we were to do a full switch to this new device that I have potentially made, if the math and physics work out, global savings potential up to $157 trillion over 30 years. Energy independence, local self-sustaining power everywhere. Environmental benefit, end of mass mining, emissions, and landfill battery waste. Legal note, multi-country certification and integration required, obviously. Deployment timeline, early prototyping by 2025, scalable deployment through 2035. That means in 10 years, we could replace the entire electrical system on all this electronics. It changes everything in 10 years. Potentially. We'll go to internal power source. because I'm pretty sure everybody wants to know how the statistics and probability of the internal combustion engine is, or internal phone system is, isn't it? Internal power cost overview. Total cost, safe, DIY version, which means it is not just safe, it is also legally and literally, what is the word? It's legally and safety made to work. $49 to $60 USD. That means if you were to buy it solo for your little phone, if your phone had the capability to do so, $49 to $60 just to replace your battery. Mass production target cost, if factory did it, $18 to $25 per unit in bulk. Expected power output, regulated. Specifications, continuous output of 5 through 7.5 watts. Peak burst up to 12 watts. Voltage options, 5 volt, 9 volt, 12 volt. USB PD compatible. Power source, pure electromagnetic rotation. No fuel, no battery. Ideal use cases, smartphones, battery replacement module. That's right, you hear it right there. I put that at the very top for a reason. I'm going to hold my phone here. Smartphones, battery replacement and module, or just replacement module. Never have to charge your phone again. You never need to have a charge cord ever again. You just have a never-ending phone. Military or emergency communication devices. Wearable electronics like a smartwatch. Drones or GPS trackers. Off-grid survival and field electronics. Kind of like a camping light, because they make electronic camping lights now. What this thing avoids to make it legal and safety compliant, it avoids lithium-based combustion risk. It avoids the excessive EMF radiation. We all know that people have a problem with, putting a phone to their ear with the EMF radiation. It's gone with this device. Rechargeable cycle degradation because of the charging and the battery. And most importantly, the best one of all, reason why I made this device, no need to plug in and charge and be dependent on a cord for charging. I'm gonna tell you right now, when I make this, I'm gonna purposely make this damn device, and I am going to take my old phone. I'm gonna take my old phone right here. This is an old iPhone 5 SE. It still works. It's still operational. I could turn it on after I charge it, and the lithium battery in it would still work. I'm going to purposely find a way to open this device. I'm going to replace the battery in this device with my device right here. I'm going to use my own iPhone, my old iPhone 5 SE, as the test subject when I make this, to see exactly if it's accurate. And if I can make a never-ending battery power source in an iPhone, oh, the potential is limitless. And as much as I love my iPhone 13, I will probably end up going back to my iPhone 5 SE for a little while, because I would never have to charge it ever again. Handheld devices. Kind of like that Echo Dot Generation 4. Output 5 watts to 1A. Approximately 5 watts motion powered. Yeah, you have to use it for motion powered in a way. A compact self-contained device that generates usable energy through kinetic motion. No crank required. This is a little bit more hands-on, and I probably fine-tune it later. But for now, the self-sustaining hand device for a quick power source is literally charged by motion. No hand crank. Total estimated cost, $77 to $85. This is a safety and legal approved, robust, motion-powered generator that's compact, self-charging, and requires no manual crank. With enough motion, it can charge most smartphones or USB gadgets, ideal for off-grid, emergency, and sustainable tech applications. Probability of success. Functional prototype, 85 to 95%, based on proven principles. Kinetic energy harvesting plus boost regulation. Consistent energy harvesting, 70 to 80%. Depends on motion intensity and frequency, ideal for walking and traveling. Charging small USB devices, 65 to 75%. Achievable with 2 to 4 hours of movement, enough to charge a smartphone. Bottom line, if carried or used regularly in a backpack, this generator can consistently charge devices over time without sun, crank, or an outlet. Perfect for minimalistic tech and emergency kits. Power output estimations. Average power output is 100 to 400 megawatts, or I don't think that's megawatts. I don't remember what that it stands for, but it's not megawatts. Megawatts is capital M with a capital W. But anyways, it basically smaller than a kilowatt. 0.1 through 0.4 watts. Peak output during motion bursts up to 1.5 watts in short spikes. Boost output via MT3608, 5 volts at 200 through 500 mA regulated. Daily harvest typical movement if you're out pretty much all day for your standard 8 hours a day, 4 through 6 watts an hour per day. Realistic use cases, charge one smartphone every 1 to 2 days, depending on motion activity. That's right. You would charge your phone, and based on this new tech, if you needed to charge your phone, it would literally be a day or two, depending on motion and activity. Power USB lights, emergency radios, GPS, or even small fans. Acts as a fully passive energy source. Charges while you walk, move, or travel. Now, you're probably asking, why did I make a design like this? Well, that's simple. If you saw in my previous for the 30-year prior and the 30-year future, it's not going to be just a simple overnight switch. So this small handheld device is kind of my way to bridge that gap while everything changes. Honestly, we need most of us, even me, use internal battery in our phones. In order to make this switch possible and more feasible while still having very little time and effort, it is best to have a device based on the same design that can just do a quick charge whenever needed for motion. And don't need to charge it with a power cord, don't need a crank, you just walk. You just produce motion with it. Now, car engines. Legal and safety compliant magnetic engine for vehicles. Again, like I said in my disclaimer, device names are not final. They are general names and have no meaning on final name of devices. Again, these are just general names. Legal safety, compliant redesign. Electromagnetic interface. Crash and structural safety, high voltage handling, thermal safety, vibration and shock, fire prevention, component certification, maintenance and inspection, environmental compliance. All right? I'll let you pause the video right here. I'll stay quiet for about 10 seconds before I continue. That way you have time to pause the video and literally come back. And you can read the compliance and safety measures that I implemented into the car engine. All right. for those of you that are still here or didn't pause, prototype for this estimated thing for the legal edition to make it legally certified is $2,000. Well, it's $3,000, $2,900 to $3,200. And if you were to mass produce this in a factory, $1,000 to $1,300. Output estimations on cruise mode, 80 to 100 kilowatts power output, voltage 400 to 600 VDC, torque 250 to 300 Nm. Boost mode up to 140 kilowatts, up to 800 VDC, 400 plus Nm. Runtime, continuous, self-sustaining, and closed loop. Safety systems overview, because, legal and safety. Thermal trip protection, over voltage safety, impact auto disconnect, electromagnetic containment, and self-monitoring system. I'll give you 10 seconds to pause or just chill. But for those that want to pause and read the descriptions, you can. I'm not going to read the descriptions. I am running out of time. All right. Legal deployment path. To legally deploy this technology in public vehicles, I gotta have a prototype phase, private internal testing on closed courses or private property, laboratory testing, certification through accelerated labs, vehicle integration, pairing with EV chassis, retrofit or custom OEM, approval pathway, FMVSS compliance, and ECE type approval, insurance testing via certified safety labs for legal coverage and public operation. You know how I said that the government and the tech companies and everybody doesn't think I could produce a legitimized, limitless energy device? I think by now, based on what I've said, they might be worried. If any tech company, if even anybody in the government, even Trump is currently watching this, they might just be worried very, very soon, because I may have just come up with the best first ever generator design since Albert Einstein. Now like I said, my redesign for Generation 2 that my Uncle Carl doesn't have. Purpose, high efficiency, magnetic propulsion generation with smart self-regulation, safety, and large-scale expandability. Very large words, right? Physical specifications. The height, optimized spec, 10 feet, 3.5 meters. Diameter, that's a circle, 16 through 18 inches, 40 to 45 centimeters. Material, aluminum alloy shell, plus vibration damped core. Weight, 150 to 200 pounds, fully loaded. Safety maintenance. In fact, right now, because I'm running out of time, I'm just going to kind of just quickly go over this very, very slowly, because there is a lot here, and I will literally give you time to read it. Keep in mind that you'll have to read the left side, and then when I scroll up, you'll need to read the right side. So I'm not going to spend too long, so you'll probably have to pause. I will say this. Continuous output for this device, 2.5 through 3.5 kilowatts. Peak output, 6 to 8 kilowatts in short bursts. Daily energy, 85 to 100 kilowatts a day. 85 to 100 kilowatts an hour a day. Yearly output, 31,000 through 36,000 kilowatts an hour a year. System lifespan, 10 to 15 years with maintenance. Maintenance interval every 6 to 12 months. Cost fully optimized, $22,000 to $25,000. Now I'll be quiet for a minute. Oh, well, you got a little bit of idea on this, so I'll have to blotch that out in the video and literally make it so I can't actually show my cost breakdown of the actual parts. So shame on me for not doing my due diligence here, so I will have to edit the video for sure on that particular part at 35 minutes. I will read this. Success probability and power forecast. Evaluation factors. Physics and propulsion. High confidence level. Control systems. FPGA. AI. High. Component availability. High. Assembly complexity. Medium to high. Full system integration. Medium. Maintenance safety. High. Estimated success rates 82 to 90% with proper materials, tolerances, tuning, and shielding. Estimated output capabilities. Sustained power is the same as before. Coverage. The actual coverage is full modern home plus EV charging. Summary. 35,000 kilowatts a year, with an average output of 4 kilowatts, with a max output of 10 kilowatts for one pillar design. These new retrofitted plants for decommissioned coal plants are as such. We'll explore layout, density, power output, site optimization, probability of success at industrial scale. Now, I will read this, which means we will probably run over the hour, and we will literally have to post it to YouTube and say, hey, go here. But that's fine. Coal plant conversion with generation 2.0 pillars. Assumed facility dimensions for typical decommissioned coal plants. Main turbine hall, 300 to 500 square feet. Ceiling height, 40 plus feet. Removed boilers, turbines, coal conveyors. Retained transformers, grid connections, and structural supports. Usable space for pillars, conservative floor area, 35,000 square feet. Per pillar footprint, 16 square feet, 4x4. Required space with spacing, 20 square feet per unit. Pillar capacity and facility. 35,000 square feet divided by 20 square feet equals one decommissioned coal plant could potentially hold 1,750 of these pillars. Total output for these pillars in this decommissioned coal plant, just one of these, is 400 kilowatts per pillar sustained with 10 kilowatts peak, just like we saw in the single thing. Sustained total is the max times 4 kilowatts is 7 megawatts. Peak capacity at max is 10.5 megawatts. Daily output now jumps to 175,000 kilowatts a day. Annual output is 63.8 gigawatts a year. Comparable to small fossil fuel plants, but clean, module, and scalable. Operational scenarios. Best case, 90% operational capacity. Sustained 6.3 megawatts. Annual 57.3 gigawatts a year. That is the best case. Sustained and annual consistently. Real world conservative estimate. 80% uptime and 85% active units. Sustained 5.95 and annual 52.3 gigawatts a year. And that's the real world estimations. Probability of retrofit success. Structure feasibility. Existing floors, ventilation support, high confidence. Grid tie-in compatibility. Reuse of transformers and wiring. High confidence. Logistics and manufacturing. Module prefabs manageable. High to medium to high confidence. Maintenance integration. IoT monitoring and diagnostics. High confidence. Permitting and regulation. Clean energy validation required. Medium confidence. Noise and EM interference. Shielding enclosures prevent issues. High confidence. Overall success, 85%, with full-scale pilot deployments up to 90% plus. Retrofit cost estimate for 1,750 units, $35 million at 20K unit. Infrastructure and systems, $5 million. Total projected cost is $40 million. Let me do a little bit of math here. Alexa, max volume. Alexa, to build a new coal power plant, how much does it cost?
From DemocratandChronicle.com. A new coal-fired power plant could take 7 years to build and cost $5 billion.
You heard it from Alexa, which pulls from potential realistic numbers off the web. $5 billion to build a new coal power plant. And just refitting one of these, $40 million. $5 billion to drop like a rock to $40 million. Just for a retrofit. Energy output, emissions, zero, clean, and modular. Everything else you already know. How many homes or businesses? Homes powered at 64 gigawatts a year, divided by 11,000 kilowatts a home a year, 5,800 homes. Range 4,500 to 5,800 based on region and usage. Small business powered. Same thing. 64 gigawatts a year. 40,000 divided by 40,000. 1,600 businesses. Range 1,200 and 2,500. Mixed use scenario. Assume 75% power homes, 25% power businesses. Here's a statistic. The result for that statistic would be 4,200 homes or 400 to 600 small businesses. National grid comparison, U.S. electricity stats, EIA, annual use that we use is 4,000 terawatts. We use 11 terawatts daily. Sustained demand for our own electrical grid is 450 through 500 gigawatts of sustained demand. For one generation 2.0 power plant output for this, annual 64 gigawatts is sustained at 6 through 7 megawatts. Plants required for a total U.S. grid replacement for 4 million gigawatts divided by 64 gigawatts is 62,500 plants. Yeah, that's a lot of plants. Alexa, how many decommissioned power plants are there in the USA?
I don't know that.
You do too. Fine, I'll ask ChatGPT. All right. How many decommissioned power plants or facilities are there in the USA? All right. We're going to do this to pace us in. So as of April 2025, the United States has decommissioned a significant number of power plants across various energy sources. Coal-fired plants between 2010 and 2019, over 546 coal-fired power plants were retired. Additional refinements have occurred since then, with plans for more in the coming years. Nuclear power plants. 12 nuclear reactors have permanently closed, with the most recent being Indian Point, Unit 3, on April 30th. 32 power reactors have been closed and decommissioned in the U.S. All right? Now, that means, based on that, we have 546 plus 32. That's approximately about 600 or 568 decommissioned plants. That means we would have to build, Alexa, 62,500 minus 668.
62,500 minus 668 is 61,832.
That's your new total of what you would need. That's your new total. Alexa, repeat that number.
62,500 minus 668 is 61,832.
Alexa, repeat.
62,500 minus 668 is 61,832.
That means we would need to build 61,832 plants to make up the difference right now. Now, you would say that that's probably pretty outrageous, and you're probably right, but is it worth being independent? Because now we're into the final phase of this video. The one thing that actually makes space travel, human space travel, possible. This one is completely theoretical. It is completely theoretical. There is nothing here that is factual. There is nothing in this next page that is actually truthful that I can think of. It is just 100% theory based on these current 5 device variations. I took these 5 device variations and literally did a theoretical space information of what we could do. Theorized propulsion system for space launch and asteroid belt mining. Elon Musk, you better listen up. Core technology of this magnetic, what I'm calling right now as a general term, magnetic pillar arrays. What is it? Delivered from new energy plants.txt and an internal power source txt. The Peller system generates sustained clean energy using advanced electromagnetic fields, likely a blend of induction, magnetic flux manipulation, and resonant energy cycling. Key traits: sustained power output 4 to 10 kilowatts per pillar, scalable, zero emissions, modular and compact design, self-contained, functional, even in a vacuum like space. Onboard power system, internal microplant. Referencing internal power source.txt and small handheld txt, portable electromagnetic kinetic power units are scalable. Combine multiple units for continuous onboard energy. Redundant power plant cores can support life systems, propulsion, and mining equipment. This ensures long duration missions and are fully self-sustaining, essential for deep space travel and asteroid operations. You know those rovers on Mars right now? If they had this design, they wouldn't be breaking down. There wouldn't be a time limit. The other parts would break down before the power source broke down. 3. Propulsion method. Magnetoplasma plus magnetic rail hybrid. This is the ultimatum for human space travel. Phase 1. Earth to orbit launch. Magnetic rail assist launch. Maglev style track. Based on Pillar Tech, install a railgun style accelerator with staggered magnetic pulses. Using superconducting linear acceleration similar to a mass driver. Pillars power each section to create a rapid launch sled that propels the vehicle into orbital speeds at 7.8 kilometers a second. Light chemical or ion boosters manage drag and angular correction during ascent. I'm going to see that again. Light chemical or ion boosters manage drag and angular correction during ascent. We could literally transform the International Space Station to do the exact same thing. We wouldn't have to decommission the International Space Station. We could actually recycle it and make it better. This design for Phase 1 is comparable to Star Tram concept, but powered entirely by internal pillar grids. Phase 2, in-space propulsion. Plasma ion drive hybrid. This is going to be the fun part. We're going like good old Star Trek right here. Plasma ion drive hybrid. Internal pillar cores generate energy to ionize gas into plasma. Magnetic acceleration coils, pillar powered, thrust ionized particles at 30 through 100 kilometers a second. No combustion through propulsion uses. It has no combustion, and propulsion uses only magnetic force plus plasma. It equals clean, efficient space thrust. Advantages: extremely high ISP fuel efficiency, long-range compatibility, ideal for asteroid belt missions, continuous 24/7 operation via onboard pillar power. Construction strategy: scalable vertical launch towers. From onehouseSizePillar.txt, the pillar infrastructure can be scaled into space elevators or electromagnetic launch towers. Expansion options are stackable pillar modules, vacuum tubes, gyroscope stabilizers, and magnetic control arms. And materials: graphene reinforced carbon fiber, mu metal trusses, and nano insulated cables. It can be taller and wider in configurations. Taller, it uses pressurized piston-style magnetic propulsion for vertical growth. Wider, interlinked pillar cells connected via magnetic flux bridges. The result: a self-powered elevator or vertical launch tube from Earth to low Earth orbit, LEO. Asteroid belt mining stations. Once in orbit, deploy modular mining ships powered by internal pillar units. Each ship powers mining lasers, electro drills, onboard fabrication labs. Use magnetoplasma drives to hop between resource-rich asteroids. Launch drones powered by mini pillar cores adapted from the small handheld.txt. Final system overview. Launch, the technology: magnetic rail accelerator plus boosters. Source: my new energy plant. In space drive: pillar-powered ion plasma hybrid engine. Internal power source: TXT. Engine replacement example: TXT. Onboard power: modular pillar reactors. Internal power source: TXT and small handheld TXT. Space tower: stackable Gen 2.0 magnetic pillars. OneHouseSizePillar.txt. Mining system: self-powered ships plus drones. Small handheld TXT. Scaled versions. Mission compatibilities: Earth to orbit launches without fossil fuels, unlimited in-space propulsion using renewable onboard power, fully modular spacecraft construction in orbital dry docks, off-Earth mining, and manufacturing 100% internally powered. Now, I didn't do the actual statistics on this, but there is your 7 different things. 7 different things on this on this device in several different ways, and literally future potential space statistics. Now, if I took a little bit more time, I could probably come up with a new theoretical engine, kind of like what you see in Star Trek. You know how the shuttles go off of, hover off the ground and then take off? There would be no, magnetic launch like a mass driver. If I spend enough time and figure it out, I could come up with an engine that could literally support this generator to literally make it so it can literally be like a like a Star Trek shuttle going from Earth to orbit without needing to be launched like a rocket. There we go, people. There we go. Now, personally, I don't know about you, but I would say this 36-year-old autistic guy has something here. He has something. And if governments, particularly the USA government and Trump, can't see that, if the business people of the world can't see that, if they literally watch this video and completely and utterly like jaw dropped with all this technical specs of theoretical potential, we're looking at an entirely new way of energy thinking. The first ever limitless universal design, because Albert Einstein was famous for universal inventions. And this would be the first universal invention technically since literally of this big magnitude since Albert Einstein. This is something we would use for the rest of the human life. However many years humans stay on planet Earth or beyond. Think about it. Colony on Mars and Moon. It would take what? Trillions, if not billions, if not trillions of dollars to make a solar network for colonies on Moon and Mars? What I described here, you don't need to spend all that money for that. Just build a dome. Put this in. You got your self-sustaining dome power on Mars and the Moon. Yeah. Yeah. That's what we're talking about. That is what we're talking about. I hope this explains everything you could possibly want. I really do. Because this is big. This is big. Because if I succeed in making this prototype, if I succeed in making a self-sustaining internal power source for cell phones and more, I have done something that nobody else could. Done something that power companies couldn't. Done something that Elon Musk himself couldn't do. So many brilliant minds out there trying to make it so complicated for the ultimate power source. And I have literally, if the math and statistics and physics is right, I literally did what nobody else has been able to do with the first ever limitless design. In essentially way, in a lot of ways, the first ever 0 point energy.